perform our arithmetic operations on polynomials. Which ones? Add, subtract, and multiply polynomials. Last week we added and subtracted. Today we're going to be multiplying polynomials. Okay? It's going to get fun-er. Oh, yes. So, also, for the past couple of weeks, I've been asking you to attend to precision. Remember that? Be precise with your work. Also, when you write your sentences, make sure you write me in full sentences, whatever your answer that you're giving me. And that was Math Practice Standard number 6, attend to precision. Are we there? But this week, I'm introducing a new one. This one is Math Practice Standard number 7, which means structure. What does that mean? It means I can see and understand how numbers and squares are organized and put together as a part or a whole. What does that mean? We're going to connect numbers to squares. So pretty much today I'm going to show you something that we call the area model. That's why today I gave you the notes, because it's going to require more of you focused on what we're doing. Okay? So once again, we're still attending to precision, Math Practice Standard number 6, but Math Practice Standard number 7, which is structure, which is seeing numbers using squares or rectangles. Okay? Here we go. So with that said, our objective for today, I can multiply polynomials. Read it together. 1, 2, 3. I can multiply polynomials. So, do you know the concept for today? Yes? Tell your neighbor, please. That's the objective. Tell your neighbor the concept for today. Polynomials. We're still on the same concept that we started last week. That's why we're not writing the Freire model. Is that correct? Notice you don't have the Freire model in your notes, but I did give you steps. I gave you these basic steps. Everybody look up. The steps I gave you were step number 1, distribute. So circle with red the word distribute. So that means the very first step when we multiply is called distributive properties. Step 2, we're going to identify like terms. Identify like terms. Step 3, we're going to use properties to combine those like terms. And what properties have we been using? The commutative and the associative, right? And lastly, but not least, is simplify. So 4 basic steps. Distribute, combine like terms. How do we do that? Using commutative and associative. And from there, simplify. Everybody got it? All right, so with that said. So I'm going to introduce this piece my way, because the book doesn't do it. It jumps you right into certain parts that become a little confusing. So I'm going to do it my way. That's why I put it on the cue side. You guys see that? So I need you guys to put your pens down, please, eyes up here, and focus, because this will base yourself the way if you get the next part. So here we go. So it says multiplying polynomials, but right now we're going to be multiplying monomials. Here's a monomial, and here's a monomial. So when we multiply these, we already know that there's an invisible number that is the coefficient of this monomial. Does everybody see it? No, because it's invisible. So, but we know that it's what number? 1. So therefore, to multiply this, we're going to multiply numbers with numbers. So what is 2 times 1? 2, and I just bring down the x squared, and I'm done. Okay, that's called distributing property. However, I said we were going to introduce the area model. So check this out. Here's a rectangle. The height is 2. The length is x squared. However, I said that the coefficient of x squared is 1. So therefore, what is 2 times 1? 2. And I just bring down the x squared because there's no variables to multiply. We got it? Copy those 2, please. And as soon as you're done with those, see if you can do B by yourself. It's very similar to the one we just did on A. Okay? Go. Okay, let's see. Who did this? 4 times 3, that's 12. You bring down the x squared. Hands if you got that. Okay? And the area model, of course, you do your area. The height is 4. The length is 3x squared. And then you drew your arrow saying 4 times 3, that's 12. And you bring down the x squared. Hands if you did that. Okay? Good. Once again, I want to see it both ways, distributive property and the area model. Because this is math practice standard number 7, connecting numbers to what? What did it say? Squares, is that correct? So we're doing something similar because we're connecting it to areas, and areas are in square units. Okay, let's do this one together. Everybody look up. So I'm going to start with red. What is 4 times 7? 28. Then I'm going to green. What is x times x? X to the second, and we're done. Okay, let's use our area model. Here it is. I'm going to write 4x and 7x. So therefore, 4 times 7, that's 28. And x times x, that's x squared. See if you can do D by yourself. Also, distribute and use the area model. Okay, so for D, should have multiplied negative 8 times 5, that becomes negative 40. And x times x squared becomes x cubed. Hands if you got that. Okay, and then your area model, once again, you draw your rectangle. Here it is. Negative 8x, 5x squared. Negative 8 times 5, that's negative 40. And x times x squared becomes x cubed. Okay? And if you forgot your properties, when we're multiplying variables which have, or that have the same base, exponential expressions, what happens to the exponents? We add. Are we there? All right. So then, now that I did a good introduction, now we're slowly coming into the fun part. Here we go. Example number 1. All right, so let's do this one together. Look at 1. It's right next to that on your notes. Let's do it together. So, what is 6 times 3? 18. Okay. What is y to the 3rd times y to the 5th? Y to the 8th. And we're done. And then, thank you, yes. Draw your area. This is 6y cubed. 3y to the 5th, and this is 6 times 3, that's 18, and y cubed times y to the 5th becomes y to the 8th. Okay, continue. Look at B. Do B together again. What is 3 times 9? 27. What is m times m squared? M cubed. And what is n to the 2nd times n to the 1st? N cubed. And we're done. Okay, let's draw our area model. We got 3mn squared. And this one is 9m squared n. Okay, and once again, 3 times 9, that's 27. M times m squared, that's m to the 3rd. And n squared times n, that's n to the 3rd. Piece of cake? Yes. Yes, question. If there's 3 what? Variables, you continue multiplying. Oh, 3 different ones? Okay, I'm going to show you that one. Okay? All right, pens down. Let me go over the next one. Okay, here it goes. All right, check this one out. Now this one, we're not going to do with the area model, and now this one has more pieces to it. But it works about the same way. That's why for this one, look at the steps that I gave you. Step 1, we distribute. Is that correct? Step 2, combine like terms if you can. Step 3, use properties. On this one, we're going to use a property, so check this out. Since there is multiplication throughout, remember the commutative property of multiplication said it doesn't matter the order of the numbers, the product is the same. Are we there? So check this out. So, I'm going to focus on the numbers only. What is the coefficient of this monomial here? 1. Coefficient of this one is 1/4. Coefficient of this one is negative 12. But when we multiply them, all of them, which is the only one that's going to be absorbed? The 1. Is that correct? So check this out. I'm going to go straight with this one. 1/4 times negative 12. I'm going to write it here. 1/4 times negative 12. Just pay attention, please. And I can write that over 1, so this becomes negative 12 over 4, which becomes negative 3. Okay? Next, s squared times s. I'm going to write it here. S squared times s. Do I have another s? Yes, times another s, which is right here. So look at it. What is s squared times s times s? S to the 4th. Okay? Next, t squared times t. I'm going to write it here. T squared times t. And then whatever I get here times t squared. So what is t squared times t squared? T to the 5th, and I'm done. But now check this out before you copy. Who sees that I just did here the commutative property? I moved the numbers together, the s's together, and the t's together. From there, to simplify, can I just do this associative? And that's how I get this. Is that correct? Copy that, please. All right. So now, so far so good. We've been multiplying monomials times monomials, monomials times monomials, and here monomial times monomial times monomial. And notice that this is the only one we didn't use the area model. Is that correct? So we did examples 1A, B, and C. Notice on your paper to the right of those, you have D, E, and F that are very similar. Is that correct? Do those by yourself. See what you get. And I want you to find me, bless you, find me the product. Use distributive property, bless you, and use the area model for D and E. Go. Examples D, E, and F. So example D is 3x cubed times 6x squared. E is 2r squared times t times st cubed. And F, it's 1/3 x squared times y times 12x cubed times z times y to the 4th and z to the 5th. All right, let's see. For this one, 3 times 6 is 18. X cubed times x squared, that's x to the 5th. Hands if you got that. And of course, you use your area model, right? This one, 2 times 5, that's 10. R squared times, oh, there isn't any. I'll do a U-turn and write it here. R squared, okay? And then from there, t times t cubed becomes t to the 4th, and we're done. Okay? Did everybody see how that worked? Okay? And F, for this one, let's see. 1/3 times 12 becomes 1/3 times 12 over 1, which becomes 12 over 3, which becomes 4. X to the 2nd times x to the 3rd becomes x to the 5th. Y to the 1st times y to the 4th becomes y to the 5th. And z to the 2nd times z to the 5th becomes z to the 7th. Yeah, because this is 2 and 5, that becomes 7. Hands if you got all 3 of them. Okay? And once again, the other 2 with area models except for this one. Okay? All right, let's move on. So now we move into fun stuff. Pens down, please, guys, up here. So previously, we did, check this out, we did monomial times monomial times monomial, yes? And then we did monomial times monomial and monomials times monomials times. So pretty much we're just multiplying monomials. Are we there? However, look at this one. We have a monomial times a trinomial. Does everybody see that? And now it's a little bit different because now this one has addition and subtraction throughout. Do you guys see that? Previously, the other ones did not have addition and subtraction. It's all multiplication. Do you guys see the difference? Tell your neighbor the difference from what we did before to the one we're going to do right now. Okay. So, pens down, please. Eyes up here. Here it goes. So, how do we do these? It's the same process. The only thing we have to check for combining like terms in between. So, check this out. Pens down, eyes up here. Step 1, distribute. 4 times 3, 12, and we just bring down the x squared. Next, 4 times 4. What is that? 16, and I bring down the x. Next, 4 times negative 8. Remember that I said if it has a negative, circle it. That's negative 32. But how does that work with an area model? Let me show you. The height is what? 4. What is the length? 3x squared plus 4x minus 8. Now check this out. This is how this is going to work. First, I'm going to separate this into terms. Focus, please. Where does this monomial end? Right about right here. Is that correct? And notice this. Can we find this area? Yeah, 4 times that. Where does this monomial end? About right here. And can we find this area? Yeah, 4 times that. And look at this one, 4 times that. So check this out. So therefore, 4 times 3 is 12, and I bring down the x squared. Next, 4 times 4, that's 16, and I bring down the x. And lastly, 4 times negative 8, that's negative 32. Everybody see that? So we distribute. Now, check for combining like terms. Is this the same type of term as this one? Yes. Look at it. Remember the pet shop when I introduced it? What kind of animal is this? This is a dolphin. What is this? A dog. So therefore, can we combine dolphins with dogs? No. Or money with all these? No. So therefore, we are done. Copy that, please. Any questions with this? Very straightforward, right? Okay, look at 2b on your paper. 2b, it's very similar to this. See if you can do 2b by yourself. Very similar. Example 2b is right next to this problem in your paper. Make sure you distribute and also use the area model. So 2b is 2 times 4x squared plus x plus 3. See what you get? Show me the area model. Let's see. For this one, 2 times 4 becomes 8x squared. 2 times, what is the coefficient here? 1, so this is 2x. And then lastly, 2 times 3, that's 6. Hands if you got that. Okay, and that's including the area model, right? Okay. So if you notice, now we're multiplying monomials times polynomials. But it's going to start getting a little bit more interesting. So copy this one in the back, please. Example 2c. 2c. And let's do this one together. Okay? All right, here we go. Let's multiply. Example 2c, 6pq times 2p minus q. And let's do this one step at a time. So here we go. I'm going to start with red. So I'm going to multiply this times this first. So first the numbers. What is 6 times 2? 12. And p times p. P squared, because this is to the first and to the first, right? And is there another, here's a q, but is there another q on this term? No, so I just write it next to it. Everybody see? Okay. Next, I circle it again. I'm going to do it now with blue, and I'm going to go to the second term, to this term. Okay, so 6 times, what is the coefficient here? Negative 1. So what is 6 times negative 1? Negative 6. Okay. P times, is there a P right here? No, so I just write it right here. And what is q times q? Q to the second. Okay? And of course, the area model would look something like this, 6pq. And this is 2p minus q. I draw a line down here at the end of that term. So this is 12p squared q. And this is 6p q n squared. And it's a negative. Now look at them. Can we combine anything here? Remember, to combine, they need to have the exact same variable with the exact same exponents. So do they have the exact same variables? Yes. But do they have the exact same exponents? No. So we're done. So? Okay, do this one by yourself. Example 2D. 2D. Copy that one. See if you can do that one by yourself. Do distribute and use your area model. Okay, so let's see. So I'm going to start with red. So let's see. 3 times 5, 15. A times a squared. A cubed. And do we have a b here in this first term? So I just write the b right there. Okay, I'm done with that term. I circle it in blue, and I'm going to go to the next term. 3 times, what is the coefficient here? 1, so this is 3. Is there another a here? No, so I just write it. And what is b times b? B squared. Can I combine like terms here? Let's see, they have the same variables, but do they have the exact same exponent? No, so we're done. Okay? And you did the area model, and you should know how to do the area model, right? Yeah. Lastly, copy this one down. Example 3a. Boom. Copy that, please. All right? So for this one, I need you to pay attention. Here he goes. Pens down, eyes up here. Now, if I was to cover this part, do I know how to multiply the s times these two? Yes. And if I was to cover this part, do I know how to multiply the 4 times these two? Yes. So therefore, the same process works for these. So check this out. I'm going to start with red, and I'm going to circle my first term, which is s. And I'm going to distribute to these two, to this one and to this one. So what is s times s? S to the second. What is s times negative 2? Negative 2s. Are we there so far? Okay. Now I'm going to do the next term. What is 4 times s? 4s. Okay. What is 4 times negative 2? Negative 8. Is that correct? So now check this out. Let's check to see if we can combine like terms. Let's see. Yes, right here. These have s's. So therefore, negative 2s plus 4s becomes what? Negative 2 plus 4, that's 2s, and it's a positive. And I just bring down the s squared and the negative 8. And we're done. Why? Because we cannot combine like terms anymore. Okay? Now, the only thing that we're missing is the area model. Everybody look up, please. Here's my area. Now I'm going to write this one. Everybody look up, or you're going to miss it. S plus 4 goes here. S plus 4. And on top goes what? S minus 2. Where does this end? Right here? I draw my line down. Where does this one end? About right here. So I draw a line across. So now check this out. What is s times s? S squared. Everybody seeing what I'm doing? What is s times negative 2? Negative 2s. So far, so good? What is 4 times s? 4s. And what is 4 times negative 2? Negative 8. Do you see that it's the same thing that I wrote here? And I can combine these right here to get that. Okay? Homework is found on page what? 451. 451, numbers what? 27 to 63 odd. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow. Or tutoring, those of you that are coming. Bye.